Hello students, hope you are doing well. Today we are going to discuss another topics from the physical pharmaceutics like spreading coefficient, solubilization, detergency and surface free energy. These all are the remaining topics from the physical pharmaceutics 2. This is Suryam, Assistant Professor, Department of Pharmaceutics, Vishnu Institute of Pharmaceutical Education and Research, Narsapur. Let us start the topic. First, we will start with spreading coefficient. Spreading coefficient means if any substance is spreading on the another surface, that entire phenomenon is known as spreading, and the amount of spreading one molecule on another molecule surface, that is considered as coefficient. As per the definition, it is a parameter to measure of the tendency of a liquid to spread on the second surface is called spreading coefficient. Example, if you observe the oleic acid in water or ointment creams on the skin, what happens if you apply the ointments or creams on the surface? We need to rub it, like we need to apply some energy. So the ointment or cream which we applied on the skin will spreads on a particular area on the skin surface, and this entire phenomenon is known as spreading coefficient. As we just now discussed the oleic acid in water, also we can take an example of spreading coefficient. In this diagram we will be having two surfaces. So this is number one surface and this will be the second surface. So if we take, this is a first surface. On this surface the oil molecules may spreads throughout the second surface. This entire phenomena is known as spreading coefficient. Here we need to consider two spreadings. First, that is a very slow spreading, and second thing is that is fast spreading. So this spreadings, fast or slow spreadings, will be depends on various reasons, whether the nature of the substance and the nature of the surface, the nature of the second surface which is to be spread over through it. Like just now we discussed, spreading coefficient will be in faster in case of some substances, and it will be very slower in case of some substances. So the reasons, basically the spreading coefficient depends on various factors like surface tension. Already we discussed in the previous classes what is surface tension, and the detailed class we discussed. And this surface tension means the force which acts on surface only. This is known as surface tension. Second factor, that is interfacial tension. This is the phenomenon which can form a boundary. This is known as interfacial tension. This is also discussed in the previous classes. Adhesive forces, the attraction forces between two same molecules, that is adhesive force. Cohesive force, this is the attractive forces between two different molecules. So the spreading coefficient is mainly depends on the following factors like surface tension, interfacial tension, adhesive forces, cohesive forces as well. To understand the spreading coefficient in detail, we need to discuss about two different conditions, like the work of adhesive force. Just now we discussed the spreading coefficient is also depends on the cohesive forces and adhesive forces. So we need to discuss about the work, how much work or how much forces has been applied to get a good spreading coefficient of the substance. And the second thing is work done at adhesive forces. If we discuss in detail about these two forces like adhesive and cohesive forces, we will know the spreading coefficient values. Let us start with the work of cohesive force. The work of cohesive force is defined as the energy or force that required to separate same molecules is known as cohesive forces. To understand this cohesive force in case of spreading coefficient, let us take a same sample in a beaker. So this is a sample, we can consider it is as water sample, and when we apply the force to separate this water molecules in two portions like this, here we will get a surface and we will get two different surfaces, and this will be 1 centimeter square and the area of this one will be 1 centimeter square, and here we will be having the same water molecule because we are discussing the cohesive forces. At this point we can find a new surface area, that is gamma L, and in the second part here also we got another new surface area, that is also gamma L. This is the liquid sample or water sample. So as per this concept, this work done at cohesive force, that is the separation forces between same molecule. So in this experiment we got two new surface areas or new surface tensions from the single one. Here we have initially the single liquid or water substance, while we are applying the cohesive force on this we have divided into two different portions, and at these two different portions we got two new surface areas. So this concept can be written in mathematically as WC is equals to gamma L plus gamma L. Finally we can write gamma WC is equals to gamma 2L. So by using this equation we could find the work done at the cohesive force. In the second case, that is work done at adhesive force. So already we discussed adhesive force means what? The force which acts in between two different or two immiscible liquids is known as adhesive force. To define the adhesive force, the energy or force that required to separate two different, as we just now discussed, two different immiscible liquids is known as work of adhesive force. Always this work of adhesive force is directly proportional to the adhesive force is directly proportional to the spreading coefficient. Similarly, to understand this adhesive work done at adhesive force, we need to take a sample which is immiscible, that is two different liquids here like this. This is a single sample, this is the second sample. These two are immiscible each other, immiscible liquid. To this immiscible liquid, if we apply the adhesive force, because of this adhesive force it will again divides into two portions. We can consider this second part as L, this first part as S. So while we are applying the adhesive force it will be divides into two portions, and here we will get the new surface tension, that is gamma L. This is liquid sample, and here we also get another new surface tension, that is gamma S. Here only gamma L. and at this portion as we have a immiscible liquid, so the surface tension of this immiscible liquid will be written as gamma ls. So the work done at adhesive force can be written as surface tension of the liquid and surface tension of the solid minus the interfacial tension. This can be used to measure or to know the work done at adhesive force. Let us consider this is as second equation. As we discussed, the spreading coefficient that is S is equals to WA minus WC. That means work done at adhesive force and work done at cohesive force. So let us substitute the WA and WC values in the above equation. So it can be written as WA gamma L plus gamma S minus gamma LS minus WC values 2 gamma L. Here 1 L, 1 gamma L gets cancelled. So finally this spreading coefficient gamma S minus gamma LS plus gamma L. By using this equation, we can calculate the spreading coefficient. Now we'll discuss the applications of spreading coefficient. It is the major factor to consider in preparation of ointments, lotions and creams, because in the example we discussed about the ointments, creams and lotions while we are applying on the skin. So the ointment or lotion should be spreads easily and uniformly. So that is the reason we need to maintain proper spreading coefficient values in preparation of these lotions, creams and ointment as well. To maintain stability of emulsions, like we will be having different types of emulsions: oil in water of type of emulsion and water in oil type of emulsion, and we will be having multiple emulsions again different types, like oil in oil type, water in oil and water type of emulsions. So we need to maintain proper stability by adjusting the spreading coefficient. In tablet coating, especially in film coating this spreading coefficient should be maintained, because this film coating tablet will be finished very smoothly. We need to finish it very smoothly. So that means we need to adjust the spreading coefficient. We need to ensure that all the tablets are undergone proper spreading by the dye or not. We need to ensure that. It also helpful in the absorption of medicament like creams and lotions. So we need to have a proper spreading on skin. That is about the spreading coefficient in detail. Next we'll start another topic, that is solubilization. In general, solubilization can be defined as the efficient of dissolving a substance into a solution. That is considered as solubilization. The ability of a substance to dissolve in a solvent is also known as solubilization. Here we have another definition, that the spontaneous interactions of two or more substances to form a homogeneous molecular dispersion. This is also called as solubilization. So here, if we have two different substances, let us consider this is substance 1 and we have another substance. So this another substance, when we mix together, they will get uniformly soluble in each other. That means there should be dissolving process should be there, and this phenomenon is known as solubilization. Example, let us take an example like sodium chloride in water in water. When we add the sodium chloride as salt in water, immediately the sodium chloride will be get dissolves in the water. So here the water will act as a solute. Here this water will dissolves the salt or sodium chloride. This also known as solubilization. Oleic acid in water. So when we are comparing this sodium chloride in water and oleic acid in water, this will be high soluble substance, and this oleic acid in water, we can say it as a poor solubility. And to enhance this poor solubility to maximum solubility by means of to increase the solubility or to enhance the solubility, we can do it by adding the surfactants. So different surfactant we discussed in the previous classes: positive surfactant, negative surfactant, amphoteric surfactant, and like non-ionic surfactant. So based on the requirement, we can add any type of these surfactant so that the solubility will be enhanced by means of the solubility will be increases. Say for example, we discussed just now oleic acid in water. As we know that this is having poor solubility property, so what we need to do, we need to enhance the solubility property of the oleic acid. For that we need to add some surfactant. So if we are taking this oleic acid, it is like in oil portion. So when we add surfactant to this oleic acid substance, all tail portion will form like this, and thus it may increase the solubilization property by formation of micelle. We discussed in detail about this micelle in the previous classes. Now we'll discuss the applications of the solubility. So to maintain the bioavailability, we definitely need to have more solubility. If you have a low solubility property of the substance or of the drugs, the bioavailability will be very less. And to form co-crystals and polymorphs, to improve the drug delivery in some formulations like emulsions, especially emulsions. In controlled drug delivery system, especially in lipid based formulation, so we need to maintain the proper solubility, or we need to enhance the solubility. If the solubility is poor, definitely the solubility will be poor for some substances. To avoid this problem, to overcome from that problem, we need to add surfactants. By adding this surfactant, we can enhance the solubility. So when we increase the solubility, we can find all these applications of the particular solubility. And the third topic is detergency. So this detergency is one of the important topic from this physical pharmaceutics. So definition of this detergency: it is a process of cleaning of any dirty or any contaminated particles from any surface by solubilizing, suspending, and emulsifying by adding surfactant. This process is considered as detergency. To explain this, we need to remove the dirty particles or unwanted or contaminated particles from a substance, and during this removing or cleaning process, we need to undergo three different mechanisms. So the detergency can be done in three techniques as follows. First one, solubilizing. First we need to solubilize the surface which contains the dirty particles or unwanted particles, and then we'll go with the suspending. We need to suspend the surface which contains dirty, and then emulsifying. So these three steps will helps to get an ideal detergency. Example, in the pharmaceutical industries, we need to clean the ampoules, and syrup bottles, cleaning or washing of cloths. This can be considered as example of the detergency process. So let us discuss how the detergency process or the mechanism will be there. So as we discussed, in the mechanism of the detergency, there are three mechanisms are involving: solubilization, suspending, and emulsifying techniques. So how this detergency is going to takes place to clean a surface, let us discuss step by step process. If the dirty particles are there on any surface area, and to this surface area we need to add surfactants or detergents. The surfactants or detergents like SLS, sodium lauryl sulfate, can be added, and then while we adding this surfactant and detergents, the surface will get wetted. After that, this cleaning process will done in three steps. First one, removal of solid dirty particles. In the second step, removal of insoluble dirty particles. In the third process, removal of soluble dirty particles. And so now this can be said to be converting to foam. So here this mechanism is known as dirty in solution, and the first technique, that is solubilization, and this technique suspension or suspending technique, and this is emulsifying technique. And now after this converting into foam, we need to add some water for washing. After adding this water for washing, we can get clean surface. Thus the mechanism will be takes place. To understand this mechanism of detergency, let us consider a diagrammatic structure. So here we'll be having a surface like this. On this surface we have some dirty particles like this, and these dirty particles has to be removed. This entire phenomenon is known as detergency. So how these dirty particles will be cleaned as per the previous mechanism? By adding detergents or surfactants. So what will happen? This detergency will be depends on three different mechanisms just now we discussed. First one, solubilization. Second one, suspending. Third one, emulsification. So after adding these detergents or surfactant, these dirty particles will be washed off. That means the surface, this is the dirty surface with dirty particles. After adding the detergency, now we'll see cleaned surface. So During this removing of the dirty particles, as we just now discussed, we have first one, solubilization, the surface of dirty one. Second one, suspending technique. And third one, emulsification technique. Now this surface is said to be removed dirty particles. Now we'll discuss the applications of detergency. The detergency is having some important roles to eliminate the residual product from any surface area. To avoid the microbial contamination. If we not washed properly to the particular surfaces like ampoule bottles, syrup bottles particularly, which we used in the pharmaceutical industries, that will undergoes the contamination, especially microbial contamination, that may reduce the shelf life, half-life of the particular product. So to avoid that problem, the detergency or this technique should be done properly. And another thing here is to clean the equipments in pharmaceutical industries like tablet coating machines, tablet compression machines, and size reduction equipments. All these things will be contaminated by batches. After one batch, we need to start cleaning for the next batch by using this detergency techniques. This is in detail about the detergency. Next, we'll start another topic, surface free energy. The surface free energy is also one of the most important topic from this physical pharmaceutics. Surface free energy may define as the work that required to increase the area of a liquid is known as surface free energy, or we have another definition, the potential energy of molecules which help them to remain on the surface is known as surface free energy. If more surface energy that may leads to more surface area, and the more surface area may leads to more molecules. Similarly, as if you have low surface area or lesser surface free energy, that may leads to less surface area, and this less surface area may leads to less amount of molecules. As per this above concept, we can say the surface free energy is directly proportional to the surface tension, or we can say surface free energy is equals to surface tension. To understand this surface free energy concept, we need to take an example that we need to add a drop of soap water on soap film's surface. So this surface should be contains 4 edges like A, B, C and D. Let us discuss in detail about this. So in the above example, we need to have a film surface. As we discussed in the above example, we need to have a film surface which contains 4 edges A, B, C and D. On this surface, we need to add the soap drop here. This is the soap film or surface. This is the drop of soap water, and this will be the L length. We can consider as initial length. And once we applied some force, some hanging force to this surface, film surface, the force will be acted in like this hanging force. So what happens, this length will be increases. So the drop of slope will be increase its in distance from A to A dash, D to D dash. So as per this above concept, work done can be written as force into distance. It will be written as F into D. So we are applying the hanging force at the same time. At the same time, the surface tension also acts on the surface of soap film. That can be written as F is equals to gamma into 2L. Since the film now having two lengths, first initial length, that is before applying the hanging force, and then after applying the hanging force. Now we need to substitute F values in equation 1. The equation 1 is W is equal to F into D. So W can be written as gamma into 2L into D. This can be considered as equation number 3. Here the distance and surface area and length, this will be increases as surface area. So we can write this as delta A. So now this W value will be gamma into delta A. By using this equation, can calculate the surface free energy. Now we'll discuss about the applications of surface free energy. This surface free energy is applicable in adsorption of gases on solid surface, and to improve the physical stability of suspensions, emulsions and colloids as well, and to improve the drug delivery system. So these are the detailed class about the spreading coefficient, surface free energy, solubilization and detergency. Hope you understood. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.